So to start off, what I always like to do is start with something and instead of a blank slate. So I have this file which I used last time. I'm just going to rename this as it's called MJ forward kinematics. Yes. And let's open this. So it's going to basically set to run the hello.xml. So we need to modify that file. Not run because it needs the hello XML and that's not in the path. But what we need to run here is we need to go to this file, this folder, and then run scene.xml because scene.xml runs the ground back. It basically shows the visuals and then the floor and then the UR5. So how do we navigate to this? It turns out that you need to give the relative path from the location of this file to that scene.xml. So in order to do that, you need to go one level up. This is the structure. Okay, so we are here. We need to go one level up and then one level down inside this folder. So the way you can do this is you can go one level up. That's how you go one level up. Then get into this folder. And in that folder is the scene file. So if you don't set this right, this will not run. Now you could also give the absolute path. Actually, what it does, it actually takes the local path, and then there's a way. Do I use? Yeah, I think I eventually take this and I figure out the directory, the absolute path, and then use the absolute path to run this. I have tried doing this without all these things, and it does not work for me, but maybe it works for you. I found this is the best way where it works on a Windows and a Mac, and it doesn't really gives you any issues. So it's up to you. There's a ways to do it without doing this whole thing which I did, which is get the directory and so on. But if you run this, it should now show the UR5, okay? And then you can do whatever you want with this. Now, this view looks okay, so I'm not going to modify this. But let's go ahead and try to now play with this. What I have to do is, if you look at the UR5, inside the UR5 is a keyframe called home. And this basically specifies some joint angles. I've actually used the same joint angles, if you see this, 6 values, as the values over here. So I can maybe load the key pose, the key from the MuJoCo file, and then that will put it in the same configuration. So we can do that in the following way. So we go. Okay, so everything here, lots of things here are, you don't really have to bother about it. But wherever you see this while loop, that basically loop runs continuously showing that scene. So that's where you will actually go and modify things. So here what I'll do is I will get the key. So how do you get the key? Well, the key is defined. There are 2 things here. There's a model, there's data. Anything in the model is a sort of a parameter of the XML file, which you will not modify. And the data is something which is modified all the time. So time, angles, velocities, forces, all these things will sit in data. And last time I showed you, you can go to the MuJoCo website and see what model int is. In fact, we should just go there because we'll need it in just a bit. So if you go to MuJoCo.org and get to documentation, here there are 2 things, the XML and then the API reference. We've always looked at XML so far, but now we'll start looking at API reference. Here, if you go to, I believe, types, there's enum, MJ model, MJ data. That's what you want to look at. So if you look at MJ model, slightly down here, wherever the struct is defined, let's see, MJ model. Those are enum types. You don't worry. We need to get the struct types. This is all the parameters are accessible. So for example, if you do model dot full stop NQ, you'll get the number of degrees of freedom. So in this case, 6 degrees of freedom. NV will give you the velocity and so on. So what we want here is, if you go down, you should see somewhere there'll be key. This is all for body. These are all parameters for joint. These are all for DOF, geometry, site, light. Keeps going. Tendon, actuator, sensor. There's this key. So we need, you could specify the key with the time. We need qpose and then qvel. The other thing you want to keep in mind is, I'll open, just open MuJoCo documentation again. The other useful thing is, if you go here and say Python here, specifically this, there's a way in which you can call this, and I've talked about this, we'll just go through it again. There is a way you can call things inside models. So for example, if you want to access, I think it's a way up there was like geometry. If you want to access some of the properties of the geometry, what you can do is you can say this M signifies model dot geom. And then you need to, if you've specified a name to the geometry in the XML, you can access it like that. And then you can put, for example, the RGBA of that gizmo seems to be the name of a geometry. And so you can access the RGBA, there'll be 4 numbers from that way. And then if you want to find the ID, everything is an ID. You can access that way, and then so on and so forth. So similarly, there is something for data, data.joint and cube. This is basically to give you the angles of joint, and that's stored in data. Anyway, so let's do we'll get to that in just a bit, but let's just use, in this case, I'll show you how to access key underscore qpose. By definition, all these definitions are for C, and so a little bit guesswork required to figure out how to do it for Python, because they don't really have this page for Python. But they're hoping that once you start using it, you know how to access it. Okay, so let's get the value. So if you do model dot key, and then we gave it a name. If you it was called home. So if you do home, and what we need from this is the tag we gave it was qpose. So qpose, and then what I'll do, I'll just say print and see what it produces. Worst case, it'll give an error. Okay, so it ran fine, no errors. You can see it gave minus 1.57, minus 1. So it basically gave this value here is just that value there, right? This value. So we got that. That's how we access variables, and this is we'll keep doing that. Okay, so we got that. Now I'm going to store it as something else. So let's call it key qpose. Okay, and then what we'll do is we'll do a few things before we go on. Let's not use this. This is for simulation, forward simulation. I'll just use MJ forward. So mj.mj forward. This is the forward kinematics. Are doing the full dynamic simulation model data. I need to set the. Okay, now I'm accessing qpose. The qpose is basically something available in data. So again, you can go to the documentation here and then get mj data. This is mj data. Inside mj data, it actually will, for example, I'm trying to use qpose. Qpose is basically the position. So if I need to specify the positions, I'll use qpose. So data.qpose is how you can specify the positions. And what we need to do is we need to store the values inside here. So key underscore qpose. And then always remember, you want to pass by value, not by reference. So you do copy. So that means that the value stored in qpose will go here. If you don't put the copy, then it will basically reference by, I guess, equivalent is pointer, and that way whenever we change Q pose, it will also change Q pose without you actually assigning it, because it's referenced not by value but by equivalent of pointers. Okay, so do this, and then it will not run forward unless you step in the time. So time is also available inside data, and I can just randomly step it 0.02. Okay, so run this now. It's a parse error. In fact, I really did something really bad here. I've never seen this kind of red error. UR5. Hey, what's wrong? Okay, let me just backtrack a little bit and see what's going on. Okay, this runs fine, I think. Okay, this runs fine. Will this run fine? This actually will give me a problem. Let me just run this way. This is, I need to move time forward, otherwise it will not. Okay, this works fine. So it looks like this might be the problem. Okay. And I have no idea what's the problem is. Oh, it ran fine. Okay. Okay. Anyways, this is the position, which actually is also the position in animate. If you want to see it in this position always, this is what you can do. And I've showed this earlier. Go to, so when you're seeing this manipulator, there is a camera inside MuJoCo, which is viewing the whole scene. So make that one. I did some work beforehand to get you to the right camera configuration. Run this. Go ahead and adjust whatever, wherever, however you want. In this, I think in this case, it should be like this. This looks good. So close that, and then it actually gives you the orientation at which you want to set it up. So copy this. Okay, and then go down to, there's a place where I've put a comment saying that you can put the, here, just put it here. Okay, so these parameters. And then, of course, you don't want it to keep printing. So you go back and set this to 0. Okay, now we can run this, and it'll actually put it forth in the angle you wanted. Okay. Now there's a glitch here in the code which doesn't let you move the camera up and down. It only lets you move the angle. So if you want to move the camera slightly up, which is the Z position, you want to go and fix the Z here in the camera look at. So it's 0, 0, 0. It looks from X, Y, Z, 0. But if you want to look slightly from up, let's just move the camera up by 1 unit along the Z axis, and maybe you'll get, oh my God, this is not what I wanted. Minus 0.5. It's too high. It's too low. Okay, so 0.5 maybe. Okay, maybe this is a better position. I could change it right here. Distance. This basically modifies how far or close you are. So if you just put 2, then we can actually play with this if you want to do it manually. Minus, I'm going to guess, let's do it half and see what we get. Okay, it's decent to do it this way. So minus 130. I think I went more up. Let me go 180. Oh, so this changes the, okay, my bad. That was fine. I need to change this. Okay, this might be better. Slightly. This okay, I'll stick with this, whatever comes out from this. Okay, this looks good. Okay, so we got that. We were able to load the angles, and then you can always check this, right? If we had this configuration here from MuJoCo, if you go to our code and then if you do the animation, it shows you the orientation. So it looks about the same. Okay, but really verification is we have to plot the exact position and see if it gets the same thing. Okay, now we've got that. Let's try to see how we can get the location of the end effector, which was that dot on the UR5 using code. So for that, what we need to do is we need to go back to the documentation and noting that we have there effectively a site. It's called attachment site, and we need to find the location of the attachment site, and we also need to know the orientation of the attachment site. So those two things. So how do we get that? Well, we go to the documentation and try to see if there is something called for site. It turns out that there's, you can see this site expose, that gives you the Cartesian position of the site, and then site xmat gives you the Cartesian orientation of the site. Now, MuJoCo does not give you the quaternions or the Euler angles, it only gives you xmat. So you need to convert that rotation, xmat is rotation 3 cross 3, to whatever you want. So let's access that. How do you access that? Again, as I told you, you need to look at this documentation and see how to access it. So it will be data, because we used structured data for instead of D. Then we need to get site, the name of the site, and then for us, it will be expose, X for the X position and xmat. So let's go to MJ forward. Here, we will data dot site. The name of the site is attachment site, and then I said expose. So let's just check if this actually prints the value. Okay, so stop this. So it's continuously prints the value x, y, z. So it's working. Let's get the other one, print data dot site attachment site, in this case xmat. Okay, so it ran. And then if you see this value, here's something interesting. Here you can see that it actually prints 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 values. Okay. We're more used to a 3 cross 3 matrix, but it actually prints it in a line. In fact, if you look at the documentation right here, you see that it is actually n site cross 9. So it's printed as 9 values. Now, you could write your own code to take the 9 values and populate a 3 cross 3 matrix, but turns out that MuJoCo has a function already available. We just use that function. So I think it's called mat to what or something like that. Okay. Okay, so mat to quat, if you give it the mat, which is a 9 values, it converts it to a quaternion. Okay, so that way you don't have to do the work of doing this. However, you can let me just copy this and then just use it. So let's go. Let's use this, but you know what? Let me define this with jn position, and then define this. So I'm going to save that and then print it a little bit later. MJN mat will take this, should be one of the inputs. So that's the input. And then this, it's giving error because we need to, this is a function inside the package MJ. So now it's not complaining. And then we need to well, so when you have an input argument like this, you need to initialize it, otherwise it will not work. So let's initialize it as mj end quat equals np dot zeros, because it needs 4 values. And then let's pass this as an input. And then print mj end. This is the problem. Okay, run it again. Okay, so here it's printing the quaternion. Okay, so that's that. Now let's do the following, which is we've got these values from MuJoCo. In fact, let me print them slightly in a better way. So mj end effect position equals mj. Okay, so this f value essentially lets me print a string and the value of whatever that variable is after after the equal to sign, just as I've defined it. Similarly, if we do print f mj and effect quat equals mj, okay, this will print it slightly in a more better way, something which we can read and understand, right? So position quaternion. Okay, we have that. Let's me comment this. I've got MuJoCo giving me the position quaternions. Let me just do the same thing from our code. Now, we already did this with this function, which this function calls the forward kinematics. It gives me so it calls forward kinematics, it gives me the position, rotation, and then I can do print, right? So all I need to do is I need to, essentially get this same thing from, I don't really need this file. I just need to call forward kinematics. Let's do that right here. Okay, we got this. Now this has not been defined. We need to define it. And Q is also not defined. So let's go back up here and then say import forward. It's from forward kinematics, import forward kinematics. Okay, so we got that. It will not complain now, but Q has not been defined. So what we could do is, I'm just going to use Q because it's more obvious than this. So call Q equals key Q post dot copy. Okay, now it's all saved in Q. In fact, here I'm just going to use Q. It's much better. And then here I'll pass Q. It's already a pass an input. We already got the position. We can check if you want, but we have a rotation here, and we have a quaternion which will be printed. So let's convert this to a quaternion. So MuJoCo doesn't, well, MuJoCo, so you cannot use this rotation matrix inside MuJoCo because MuJoCo expects a string, well, it's an array of 9 values instead of a 3 cross 3. So we'll have to use some of the things which I wrote down some time back. So I have put all the functions which I would need in a file called utility. It does rotation, it does quat to rotation, rotation to quat, and so on, so on. You can look at it whenever you want, but you need to import this as a package. It's like a package. So import utility as, you can put some random name. Okay, I just put RAM, and then we can now convert the rotation to a quaternion. So end effect quat equals dot. So we have rotation. So I think I have a function called rotation to quat, and I provide it with. Now I'm just going to call this p and y underscore just so that I can distinguish it from the MJ. This is something which we created ourselves. Okay, so last step is just to show that both those give the same answer. I'm just going to make it print. Then I want to make it, just put a separator here. Okay. Okay, so moment of truth. Let's see if those values are the same. We have given the same cues to both. Okay. Oh, I did not uncomment that here. Let me uncomment it. Okay, here it is. This is what I got positioned from MuJoCo. And then you can see from my calculation. And then the quaternion is this, and the same quaternion. Okay. In fact, it's always a good idea to check different values. So if you want to check a different value, I'm just going to use this as a basis. Let's take this. In fact, you know what? Let's take, it's already written nicely here. Let's take this and then just modify our Q. Not needed. And then you could put whatever you want. Minus 1.23. I think if I go, I have to be careful because there's some values where the manipulator actually goes into the ground. Let's just try these values. Okay, this was okay. Okay, so here it is. End effector position, same, orientation is the same. Okay, so that's just a way to check if your calculations are working right.